so we have a real life example of where we would do a square root function and also where we might do some transformations. The function e of d equals 0.25 square root d. That equation approximates the number of seconds it takes a dropped object to fall d feet on Earth. The function m of d equals 1.6 multiplied by e of d approximates the number of seconds it takes for a dropped object to fall d feet on Mars. Why are they different? Gravity, good. All right, write a rule for m. So we're going to write a rule. That means write an equation for the m. But there is an equation for m, sort of. You have to write an equation for m, but here's the m equation right here. But what they're asking you to do is take this m equation and where you see e of d, substitute in the e of d equation. What is the e of d equation? Substituted in, whoops, what's that? We substituted in what the e of d function is. Then how can I simplify that? Well, we're not going to do distributing unless it is over addition or subtraction, and there's no addition or subtraction. So all I need to do is multiply together the numbers that are on the outside of that square root. I cannot put the 1.6 under the square root. Let's multiply those numbers together. So we have m of d equals, what do you get? 0.4 square root d. So that is the rule. That is the rule for m. Then it says, how long does it take a dropped object to fall 64 feet on Mars? I'm not going to plug it into the Earth function and then take that answer and plug it into the Mars function. I'm just going to use the new Mars function. So we're plugging in what number? So we're going to do m of 64 equal to 0.4 square root 64. So wherever I saw a d, I now made it a 64. So I get 0.4 times 8, which is
3.2.
what?
3.2.
Oh, 3.2. I couldn't understand what you're saying. All right, 3.2, and then this is a real life problem, so 3.2 what? Seconds. Perfect. Seconds. Okay. So now the second question, what is? In example 3, the function n of d equals 2.4 times e of d approximates the number of seconds it dropped object to from the moon. Okay. Write a rule for n. How long does it take a dropped object to fall 25 feet on the moon? So you do kind of the same thing. Use example 3 to find your e of d, and you find the rule for the moon, and then plug it in and find how long it takes. So following the exact same steps, only it's not m, it is now n that you are using. Exact same steps. So what is this? So that's going to be your next step. Put that there.
How are we using this?
Okay. Same one. Oh, that's right. So you're using the E of D.
Yeah. So I put that there, yes.
You gotta put an E function. Did you write down what we need to set up here? Okay, so where's the step up with that?
Yes. Okay. So. Cool.
You didn't write down my first step. It's on the board still. So you didn't write down the first step to see what was happening in the second step. So the very first thing that we're going to do is we're going to try to find n of d. And what is n of d? N of d is equal to, it says it right here, 2.4 times E of D. And then from example 3, I even colored it, put a big old box around it. E of D is 0.25 square root D. So I'm going to substitute right here 0.25 square root D. Messy. Sorry. Let's try that again. I'm substituting that in right there. So now I have n of D equals 2.4 times 0.25 square root of D. Then we multiply this stuff together, and we get n of D is equal to 0.6 square root D. So that is the rule. And after that, we're finding how many feet? 25 feet. So we do n of 25 equals 0.6 square root 25. So 0.6 times 5, which is 3 cycles. Okay. When you're ready to go on, turn the page. And I think, yep, that's exactly where we're going. Next page. So that's the stuff that we're going to be doing today. We're going to take a function, and then we're going to transform that function somehow. And we did this before a lot at the very beginning of the year, but we haven't done it for a while. So it might take some going back and looking at the chart a bunch of times to remember how to do this stuff. Let the graph G, so we're going to find G, be a horizontal shrink by a factor of 1/6. Then it says followed by. This means we're going to do one thing, we're going to do the first thing, and then we're going to find the answer. And then we're going to do a second thing. So when you see that followed by, that means stop and simplify what you have. And then do the second thing. The second thing is a translation 3 units to the left. And it tells us to start with the graph f of x equals cube root x. So that's going to be the function that we are starting with. What is the very first thing that we are doing? Okay, we're doing this horizontal shrink. If you forget, when we go to that chart that you have in your notes, and you go and you find where is horizontal shrink? Right there. It's true, it is. Here's horizontal shrink, stretch or shrink. We go over here, and this says to do f of, take that factored multiplied by x. It then has an example of where the number might end up. But the thing that we need to remember is if it is horizontal, we always do opposite. If it affects the x value, we always do opposite. So we go to this question. What is my factor? If it's a factor 1, 6, what is my a value? What am I going to be putting in with the x? No, because it's horizontal, I don't put in 1, 6. I put in 6. The reciprocal. So I do f of that, f of 6x. And wherever I see an x, I'm going to take out that x and I'm going to replace it with 6x. Wherever I saw an x, I made it a 6x. So that's the first thing. Then it says followed by. So that means, okay, stop, simplify. Is there anything we can simplify? Parentheses out. We don't really need parentheses, right? There might be some things that you could simplify. This time, not really. Now we're going to do a translation 6 units to the left of the graph. So how do we do a translation 6 units to the left? We can go back and look at our chart if we forget. Here's a horizontal translation. We do f of, we do x minus h. We do x minus the number. That would give us a right? Minus. So to do left, what do we do? Okay. So I'm going to do this, but I'm going to make it a plus, not a minus. I'm going to have f of x plus, how many units? 3. So in the step above, wherever I see an x, bless you, I'm going to replace that with parenthesis x plus 3, wherever I see an x. So I still have cube root 6, but instead of x, I now have parentheses x plus 3. Is there anything we can simplify with that? We can distribute that. So I will have cube root 6x plus 18. So that g of x is my final answer. That's what they wanted us to write it as. The g of x. Okay. The next one, let the graph of G be a horizontal stretch by a factor of 3, followed by a translation 6 units to the right of the graph. Is there a followed by? So we have to do one part simplified, then do the other part. We're going to start with f of x equals cube root x. And we're going to do a horizontal stretch by a factor of 3. If you forget how to do a horizontal stretch, what do we do? What do we do if we forget? We go to this chart and we say, okay, I need a horizontal stretch. I'm looking over here. Here's a stretch by a factor of 2, and they multiply by a half. Oh, yeah, that's right. We have to do opposite. Here, it's telling me to put it in the parenthesis with the x. So we're going to have f of what? 1/3 x is equal to, wherever I see an x, make it 1/3 x with parentheses. Is there anything I can simplify? Get rid of the parentheses. Okay. The second part, translate 6 units to the right. So we go to our chart, and that says to do this. X minus 6. So in the step above it, wherever I see an x, I'm going to put parentheses there and put in the x minus 6 in that spot. So I'm going to have cube root 1/3 parentheses x minus 6. Is there anything, is there anything I can simplify there? I can distribute, right. So our final answer is going to be g of x equals cube root 1/3 x minus 2. Now, I do not know, unless somebody does this on their homework and tells me, I don't know if the online book would accept the previous step where you didn't distribute. It might, but I'm not sure unless you try it and say, nope, it won't accept it, or yes, it does accept it. If anybody wants to try and let me know. Otherwise, make sure you do simplify it. Question? Wait, say that again? Oh, you're talking about that? Okay, so for this purpose, let's not worry about that. I can tell you it would be super messy because you'd have to find a common denominator. And then you'd have to multiply by 2 more 3s. It would be pretty, I'm not going to do it. Okay, well, let's not worry about that for this purpose. If the directions are just simply simplify it, then that's probably what you need to worry about. Good question then. All right, next one. Let the graph of G be a vertical stretch by a factor of 2, followed by a translation 3 units up of the graph. Write the rule for G. Then find G of 27. So how are we going to start? Now, all 3 of my examples have had cube root of x. They might give you square root. They might give you 4th root. But we really haven't used anything. We haven't used the root for any of these. We just keep repeating the root. We just keep writing it down. So it has a different root. That's okay. What do we have to do first? A vertical stretch. Where does the vertical stretch go?
Outside.
Yeah, if you forget, you go look at our chart, and we look for vertical stretch. We go here, vertical stretch, and it looks like we take A and multiply it by f of x on the outside of the function, on the outside of the function. And then it's got some examples of where I would put that number. And if I look at a stretch by a factor of 4, and then I look here and they actually multiply by 4, that might help you remember, oh yeah, I do the same thing when it's vertical. I don't switch it for vertical, I only do it for horizontal. I think I need to charge my marker. Okay, so we have, what's our, 2, f of x. That's telling us to do 2 times the function. So we do 2 times the cube root of x. Then followed by means simplify. So how can I simplify that? Just take 2 times that. The 2 does not go under the radical. So now what do I need to do? Now we're doing a translation of 3 units up. Where does that go? We do f of x plus 3. So I'm going to do 2 radical 3x plus 3. And is there anything to simplify there? So g of x equals 2 cube root x plus 3. Okay, the next example is not in there. it's not on your notes, but you probably have some space right on that same page. All I'm going to say is, what if this last question, the followed by, what if the stuff was in the other order? What if instead of vertical stretch first, what if we did translation 3 units up first? Oh, I forgot to find G of 27. Let me go back. What's G of 27? You can work ahead. 2 cube root 27 plus 3. So 2 times 3 plus 3 is 9. Sorry, I forgot to go over that. Okay, so what if, I'm going to give you a moment to try this on your own. What if we did first the 3 units up, followed by vertical stretch factor of 2. What if we did it in that order? Oh, can you try this way?
Oh, you want to try it?
Yeah. The same as this one. The same question, just what if it was in a different order? Would that affect the answer?
I don't think so.
Well, let's find out. Should. So if we did the 3 units up first, you would do your f of x plus 3. So on this side of the equation, I would do cube root of x plus 3. Then what do we do next? We're next going to take 2 multiplied by this entire function. So I'm going to have 2 parentheses cube root x plus 3. So if that stretch is the last thing that happens, it has to happen to everything. Now here's some erasing. Did we not distribute? So g of x would equal 2 cube root x plus 6. Would that be the same answer if I plugged in 27 as the first one? Okay. Yeah. We had a reflection, and if the reflection was last, it would go to everything. And this would be where we made mistakes in the beginning of the year. I remember correcting a lot of mistakes. So let's try to remember this stuff the second time around. All right, last thing we're going to do is just some graphing calculator thing. So if you can grab your graphing calculator. And we are going to type in the equation. 1/2 y squared equals x. And we're going to graph it. Okay, so we're going to go to our graphing calculator. Why not? Hold on. Go in there. So why can't I graph the equation that I just gave you?
Y squared.
Well, yeah, because this says the equation has to be y equals. So yeah, I can't make it y squared because it's already there saying it has to be y equals. So we have to change the equation so that you can use your graphing calculator. You can do it, you just have to change the equation. So how am I going to get y by itself? To cancel out half, we multiply by 2. You multiply by the reciprocal. We're doing things that are the inverse operations. You do what will cancel out. You do the inverse, the opposite operations. That's just solving equations. All right, y squared equals 2x. Still can't type it in. Okay. So by square root, nobody's going to yell it out for me? Who's got a plus or minus? Who said it? Plus or minus? If you do square root, or if you do fourth root, or if you do sixth root, you have to do plus or minus. Remember? Any evens, right? So if we have y equals plus or minus square root 2x, now we have y equals. But you can't type in plus or minus in your calculator. So we do y1 square root 2x, y2 negative square root 2x. So you get those typed in. I'm going to come around if somebody makes a mistake and it doesn't graph. Now, it looks like it is two different equations. If you have the colored ones, it looks like two different equations. But it's not, because we had to split it to put it into the calculator, but really is one equation. It's a sideways parabola. If you're not getting it, some of you are not getting it, get some help from either me or somebody nearby. You didn't do square root. Go back. You did like you did like x root. No, go back to y equals. Like you just need to use the square root. It's right there. Let me type that should be okay, the question. Which way does it open and what's the vertex? Write it down. Which way does it open and what's the vertex? Why don't you write this down? Yeah, if it's blue, then you have to, it's in blue, is that the color you're using? Yeah, if it's blue, you have to put these up first. So my vertex is where? And it opens left. Okay, next question. Oh, because see, my right is my left. No, I'm just joking. I always say I'm wrong. I promise I'm driving. I'm driving and I'm like, you need to go left here. And my husband will be like, turn left. I'm like, no, that way. That happens often. I don't know why. Okay. What happened? No. Okay. Using graphing, maybe it's because I'm always facing the other direction, and maybe that's what it is. I'll blame it on that. All right. X squared plus y squared equals 16. We're going to have to solve that one for y squared. So let's do it together if you haven't done it yet. We're going to do what to both sides? We're going to subtract x squared, we'll get 16 minus x squared. Then we will square root, and when you square root, you need plus minus. When you square root, you do not square root the 16 and the x squared, because it is not the square root of 16 and the square root of x squared.
Square root of the sum of two.
It is the square root of the difference, sum, difference, same thing. It is the square root of that quantity, and you don't know what that quantity is. You cannot square root those numbers. So you just type in your calculator. Y1 would be square root of 16 minus x squared. Y2 is the negative square root 16 minus x squared. Go ahead and type that in.
No, it's not an oval actually, because they both need a four. Actually,
It does look like an oval, and I'll tell you how to fix that.
Why doesn't mine look like that?
Oh,
yours is more straight
it looks like that house.
Did somebody else talk about it yesterday?
No, I did.
Okay.
It looks like that.
It has a setting which I'm about to do. That's what I was asking. All right. So first of all, you see how it looks like it doesn't connect?
Oh, yeah.
It does. But the calculator, like, the pixels are little squares, and for some reason where it needs to go, they couldn't really make the squares fit there. It's just technology. This is not the most expensive piece of technology, so it's not the most accurate. But I promise you, this is a circle that does connect. The second thing is, the reason why it looks stretched out is because we're looking at a rectangle. A rectangle where this is 4 and where this is 4, but they're not the same distance. So if you want it to look like a circle, like if you're like, this is bothering me, it needs to look like a circle, you can hit zoom, and you can hit 5, which squares the window. And then it'll look like a circle. It'll look more like a circle. So zoom 5 would make it look like a circle. If it doesn't bother you, that's fine. All we have to do is write down the vertices and something else I forgot. Oh, the radius. So what is the radius? From the center out, what's the radius?
4.
Now, all of you took geometry last year. You should have, oh no, some of you are in it right now. You probably have, how many have done circles yet? Have you done circles yet? Sorry, not to put you on the spot. Who else in geometry is just nobody else in Dublin right now?
Yeah, yeah.
He did. I had him. I had like a bunch of you in here. Anyway, so I know that you did it. Do you remember it? I don't know. But I know you did it. This is the equation of a circle, and it always equals r squared. So you could look at it and know that the radius is 4. Oops. Radius equals 4. There you go. And then what are the intercepts? The x-intercepts are at 4, 0, negative 4, 0, and then the y-intercepts are at 0, 4, 0, negative 4. Okay, so you have 2 others to try on your graphing calculator. Show me that you've got answers, and then you can grab your computer after that. You've got 2 others to try. You do not have to simplify it to type it in your calculator. You just need to type it in your calculator. You can, however, solve the divide by negative y, and that's really the part that.
So I divided by -4 and then
you square root.
Is it
so did you
batteries or is
y
it
squared
charger?
as the form of a negative
It's
4?
batteries because it's normal.
It might be weird.
What do you mean with
Divided by
that?
negative
What?
Okay, never
So you do not need to simplify to type it in your calculator. You just need to get it typed in your calculator. So, did you divide by -4? We get y squared equals x plus 1 divided by -4. I'm not allowed to leave a negative in the denominator, but it's okay because all I'm going to do is type in the calculator. I'm not simplifying it. So then I'm going to square root both sides, and I'll get y equals plus minus square root x plus 1 over -4. I will type that in so you can see what the graph should look like. Remember, if you have the fraction button, please use it because it'll make your typing a lot easier. The vertex is that center of the parabola, like where it changes direction. So this is what it should look like if you typed it in correctly. Ooh, I hit Zoom 6 also. So if you're still in Zoom Square, like Zoom 5, it might be a little different. But I can totally tell where my vertex is and which way it opens. To the left. Real left. No, you cannot do that because it's the square root of after you do 25 minus x squared. So that opens. It opens to the left, and the vertex is -1, 0. Before graphing, or maybe you've already graphed it, but what do you think the radius is for this circle? 5. If you're having trouble with your graphing calculator, let me know. Yeah. Okay, you're typing it in wrong. So you got to do what I'm doing, and if you don't get it, you got to stop me early. Do you have fractions on this? No. Okay, so you have to type it in so that there is an extra set of parentheses around the top. So type that in. Great. Then divide by -4, then close that other. So you haven't graphed anything yet. You've got to sit here and get help immediately. Yeah.
I got plus or minus squared.
Oh, yeah. Well, yeah, it's not negative. It's not like highlighted. Delete that. Yeah.
Oh,
Yeah.
okay.
I figured it out.
If you got the last one graphed, it looks like a circle. You have it graphed and it looks like a circle. You've got your big ideas on mine to work on.
Last one, was a circle.
What? The last one's a circle.
What?
I'll come help.
Mine didn't have it.
This is, what section, 5.3, day 2.
I don't change.
So try to pass